Hello guys, welcome to my channel. In this lesson, we're going to learn how to factor by grouping, and then we will use the skill and understanding from here to solve quadratic equations algebraically. All right, let's go ahead and do this. All right, first I am going to group 2x squared and 3x. And then after that, I would group 4x plus 6. So what I'm doing here is I'm looking for common factors. And you know what factors are, right? So factors are numbers that divide exactly into other numbers and not leaving remainders. Okay, so I'm looking for highest common factor. So I'm looking for the common factors between 2x squared and 3x. So the only factor that I can see here is x, because I can, I can multiply 2x by x to get 2x squared. Yes, and I can multiply 3 by x to get 3x. So it means x is a factor of 2x squared and 3x. So what I'm going to do here is to create this parenthesis right here, okay? So after that, I'm going to write the common factor outside the parentheses, and then I will say 2x squared divided by that x, which is going to be, if I have 2x squared divided by x, that's going to be 2x. So that stays right here. Again, the next is 3x. I'm going to do 3x divided by x. That's going to be 3. And that stays positive 3. Cool. All right, so we're going to move forward to 4x plus 6. So we have positive 4x plus 6, yeah? So here, the common factor will be 2. So again, it will be positive 2, and I'm going to open my brackets. And then I would say, okay, 4x divided by 2, 4x divided by 2 is 2. So that 4x divided by 2 is 2x. So that 2x goes here. All right, so I have 6 next. So I have 6 divided by 2, that's going to be 3. So that's positive 3. It stays right here. So good. So you know you're doing it right when you see common factors in the parentheses. So you can see we have 2x plus 3 and 2x plus 3, which means everything is good. All right, so what we're going to do here is to wrap up the 2x plus 3 and 2x plus 3 and just make them overlap. So I have 2x plus 3. And I put them together in one parenthesis, and you can see this x here. And this factor here, this is going to be x, and what, positive 2, that would make another factor, so x plus 2. So this is the procedure you must follow every time you're factoring by grouping, okay? So that means this expression right here is equivalent to this expression, and it is factored now. All right, let's look at the second one. So here we look at 2x squared and 4x. So here the common factor would be 2x, because I can do 2x squared divided by 2x to get just a single x. Yes, so 2 cancels 2, 2 divides 2, and x divides x squared to get x. So that means it's x. So 2x goes, and again 4x can be divided by 2x, and then that is actually giving 2. Yes, 2 will divide 4 to get 2, and x will just cross out x. You have 2. So that means if I'm factoring this, I'm going to first of all factor 2x out from 2x squared plus 4x. So I get 2x, then open my parenthesis. All right, so now if 2x divided 2x squared, we said we're going to get x, which is exactly this x right here. And if 2x divides 4x, we said we're going to get 2, which is just 2 right here. Good. So I'm done with that part. So I'm going to go ahead and group 3x plus 6. Now, to do that, I will just observe that I have 3 and 6. And the common factor of 3 and 6 will be 3. So that will be positive 3 now. Then you open your parentheses as well. Now, if you divide 3x by 3, what you get? You get x. And if you divide 6 by the same 3, you get positive 2. So you can see, again, you can see everything is going well. So the way we want it to be. See that? So you have x plus 2, x plus 2. So the x plus 2, I'll just wrap them up, keep it. And then the 2x and the positive 3x will make the other pair. So now this is factored and this is factored. Now we need the skill to be able to solve some trinomials. So we're going to go ahead and look at what we can do with this set of problems here that I'm about to show you. All right, so let me go ahead and remove uh, what we have right here so that we have enough room to solve more problems. And you can always rewind so that you see how I'm following the steps. All right, so just in a moment, and now we'll be done. Okay. All right, I'm trying to make everything disappear. Okay, so I am now going to show you why we are doing this. Let me show you another situation. So let's look at how we can factor the following trinomials. 2x squared plus 13x plus 6, that's one. We have another 2x squared plus 8x plus 6, and 2x squared plus 7x plus 6, 2x squared minus 13x plus 6, and so on. All right, this is what we have. So we want to learn how to factor these trinomials. And if we can factor these trinomials, just like we did prior to this, we'll be able to solve these quadratic equations algebraically or by factoring. Okay, so let's go. So um, to factor trinomials is really tricky. It's not as easy as just grouping them. So here we have four terms. Yes, 2x squared plus 3x plus 4. Let me go ahead and show you what I mean. Here you have 2x squared, 3x, 4x, and 6. And it was easy for us to just kind of group them together and do the factoring. But here you have only three terms. So you have 2x squared, 13x, and 6. It's not going to be very easy to group them and factor that the way we have it here by grouping. So that's why we're going to come up with a trick to solve, or to factor trinomials like this. So trinomial because you have 1, 2, 3. You have a term in x squared, another term in x, and a term without x. This is a quadratic expression, and this is a trinomial. All right, let's go ahead and do this. All right, to do it right, this is what we're going to do. Let me see. Let me make all of this disappear so I have enough room. Right, so to solve the first one or to factor the first one, which is 2x squared plus 13x plus 6, this is the process I would follow. So first, I would take this 2 here and multiply it with the last term. Okay, so that means 2 times 6. So I'm going to have 2 times 6. And I know that 2 times 6 would give 12. How did I get 12? I had to multiply the coefficient of x squared by the constant term. And that's 2 times 6, which is 12. So that's 12 right there. Okay. And this 12 here, we're going to make what we call product from here. So we put 12 here, and we're going to use that as the product. Okay. And this middle term here, the middle term here is positive 13. Because it's positive 13, I would just take 13. So I'm going to use this 13 as the sum, which is S. Now, this is what I'm going to do. Now, I'm going to break this 12 into two numbers such that when I multiply them, it will be 12. But when I add them, it will be 13. So this is what I'm going to do. So 12 is actually 1 times 12, right? 1 times 12 is a product, which is 12. But look what I'm going to do here. Here, I can just carry that 1 and 12, but this time I'm going to add them because S represents sum. So here I'm multiplying to get 12. Here I'm adding up to get 13. Cool, cool. All right, so since they match, you can see that there's a match here. Here you have product. Let me say product. And here you have sum. And what we have for the sum is exactly 13. And then for the product, we're getting 12. So you can see 1 times 12 is 12, and 1 plus 12 is 13. So what I'm going to do here is I am going to now replace this 13 right here. I'm going to replace this 13x by 1x and 12x. So which means this 1 here, I'm going to drop it and add x to that. Plus this 12 here, I'm going to drop it and add x to that. So that means you have 1x plus 12x. I'm going to use that to replace this 13x in this original problem here. Let's say problem 1. So if we do that, it becomes 2x squared. Instead of 13x, I'll replace that with 1x plus 12x. And then I can write 6 next, plus 6. So I'm just keeping everything the same, but I'm just replacing the 13x by 1x plus 12x. Now, if you look at this problem now, or this expression now, it's looking like what we had before. Now we can group this. Now we can now factor by grouping. But if we didn't do this, if we did not perform this, okay, if we did not go through this procedure, we wouldn't have the expression in this form. Now it is going to be easy for us to kind of group 2x squared and 1x, and then group 12x and 6. Here I'm going to look for common factors. For 2x squared plus 1x, I know the only common factor will be x. So this will be x, and I'm going to open my parentheses and have, if x divides 2x squared, I know that I'm going to have 2x left. Then plus, if x divides 1x, I'm going to be left with 1. 1. Okay? X dividing 1x is going to be 1. Okay? So then I'm going to go plus, because I know I have 12x plus 6, it will be positive. So I'm looking at 12 and 6 now. So the common factor of 12 and 6 is exactly 6. So I'm going to write that 6 and open my parentheses. So it's just looking like I'm doing I'm applying the reversed form of the distributive property. So here will be 2x. And if I divide, meaning that if I say 6 times 2x, it should give back 12x. But then, now for 6, 6 will exactly divide into 6. That means we're going to have positive 1. So that 6 times positive 1 will give back the 6 right here. So you're making sure that if you go in the reverse order, you'll be able to get the original expression. So now this is what I have. So everything is working out well so far, so good, because I have 2x plus 1 here, and I also have 2x plus 1. So I'm going to collect them together. So that means 2x plus 1, and then wrap them up. So I have x here on the outside. I have positive 6 over there. So what I'm going to do is wrap them up together as well. And this will be factored. So this is what you're looking for. So which means that this expression right here from number 1 is exactly going to be 2x plus 1 times x plus 6. And if we carry out some expansion on this, it should give the original trinomial. So now, the reason why we're doing this is for us to be able to now solve a problem like this problem 1 star. Let's say 1 star here. This problem 1 star here is a little different because this is an equation, whereas we had this problem 1 here. Problem 1 on the left is just a quadratic expression, but the problem on the right here is a quadratic equation, right? Because it is exactly equal to 0. So in order to solve that problem, since we already factored it out as, we factored this result as 2x plus 1 multiplied by x plus 6, we just set the result to 0. So now, if you have a product that's equal to 0, that's what we call the zero product principle. Okay? So you just set each piece equal to 0 from there, and you'll be able to solve the quadratic equation. So now I'm going to do it as 2x plus 1 is 0, comma, and x plus 6 is also 0. So each piece will be set to 0. So x plus 6 equal to 0. So now what I'm going to do for the first one here is subtract 1 from both sides so that I can isolate the variable. So that means 2x plus 1 then minus 1 equal to 0 minus 1. So you're subtracting 1 from both sides and crossing that out. So you have 2x equal to negative 1. And then you're going to divide both sides by 2. And you get x is equal to negative 1 half. So I have just solved the first part. Let's go to the second part where x plus 6 is 0. So if x plus 6 is 0, that means you can subtract 6 from both sides. Cross that out, you you get x equal to -6. So now the solution to this equation 1 star here would be x equals -1/2, comma, -6. So this is how you would solve this equation. This is how you solve this equation. All right. Okay. So let's go ahead and look at another problem. So look at the question number 2 here. So let's call that problem number 2. Again, you can rewind. So let me go ahead and just erase all of this again. Let's do problem number 2, and we can see the difference here. All right. So again, I am going to erase everything here. You can always rewind to see how we're going through the steps. You can take down your notes as well. So I am taking all of this away again. Sorry, I got to do this. I'm trying to make sure that we have so many practice problems. So we'll do a couple of them, and then I think you'll be able to do the rest. Okay, so let's look at problem number 2 from the left. And then whatever we do from there, we're going to use that to solve problem number 2 star on the right. Okay, so for number 2, we have 2x² plus 8x plus 6. So let's go ahead and factor that trinomial. So to factor the trinomial, this is what I'm going to do. So I'm going to multiply 2 times 6. So which means you're multiplying a times c. You know, you always have ax² plus bx plus c. This is the standard form of quadratic of any quadratic expression. All right. Okay. So it could be different. Okay, depending on what is 0, but a cannot be 0. So a is not always 0. So you always multiply the coefficient of x² by the constant term. Okay, so that's the first thing I would do. So I would take 2 times 6. So 2 times 6, I know that's going to be 12. So this 12 here becomes my product, P. Okay, but then this positive 8x here, this coefficient of x here is 8, right? So I'm going to pull it out. I'm going to bring it here and write that as the sum. So which means 8 is the sum. Okay, so I'm going to remove that 8 and use that as a sum. So this is what I'm going to do. So now I am going to break this 12 into two numbers such that when I multiply them, it'll give 12. But when I add them up, it'll give 8. So let's look at 6 times 2. Okay, so what is 6 times 2? 6 times 2 is 12. Good. But then 6 plus 2 is 8. Wow. So this is what I'm going to need. So I'm now going to use 6 and 2 to solve the problem. So now here I have 2x² plus 8x plus 6, right? So I am going to replace, let me use green here. I'm going to replace this 8 by 6 plus 2. So which means I'm going to write everything else as 2x² plus, but when I get to 8, I'm going to replace that 8x by what? 6x plus 2x. And notice that 6x plus 2x is also going to be 8x. So that's what I'm trying to do here. I'm just transforming that. Now, instead of having just a trinomial, I've been able to break the trinomial into 4 terms so that I'll be able to carry out my grouping. See? So now I have 2x² plus 6x plus 2x plus 6. So now I can group this and then factor. Here for 2x² and 6x, notice that the factor here will be 2x because 2x can divide exactly into 2x² to get x, and plus, and 2x can divide 6x to get 3. Close. Now I have positive, so I have positive 2x and positive 6. So now for 2x and positive 6, notice that 2 will be the factor of 2x and 6. So I'm going to factor that 2 out, and I'm going to have x plus 3. So if we're good, then we should have x plus 3 and x plus 3 overlapping. But if you choose the wrong factors, they would never overlap, and you know there's a problem. Okay, So now I have x plus 3, and I'm being very careful here. So now I'm going to group these two now. So I'm going to group x plus 3 and x plus 3 to give x plus 3. And I'm going to wrap this 2x up and this positive 2 to get 2x and positive 2 like that. So this is how you factor. All right. So meaning that if I wanted to solve this equation 2 star here, if I want to solve this equation 2 star here, I can easily just solve that by just copying this result and bringing that over here. So which means if I factor this expression on the left hand side, it will exactly be x plus 3 and 2x plus 2. And then since the expression equals 0, I will also set this to 0. Now, I'm going to use the zero product rule now because I know that if A times B equals 0, it therefore means that either A is 0 or B is 0. So that's what you call the zero product principle. Okay? So I'm going to now solve this problem at x plus 3 equal to 0 or 2x plus 2 equal to 0. So I'm setting each piece to 0. I'm setting x plus 3 to 0, and then also setting 2x plus 2 to 0. And then I'll solve them separately. So to solve x plus 3 equals 0, you just subtract 3 from both sides, and x is going to give you negative 3. To solve this problem right here, to solve that problem right there, what you're going to do there is to just look at the problem and say, okay, I am going to subtract 2 from both sides, isn't it? So when you subtract 2 from both sides, like subtract 2, you subtract 2 over, you cross that 2 out, so you get 2x is equal to negative 2. And then you divide both sides by 2, right? And then you cross that 2 out, you get x equal to negative 2 divided by 2 over negative 1. So which means the solution to this problem here will be negative 3 and negative 1. So that means x equals negative 3 or negative 1. And then we can always check. So when you plug in this result back into the original equation, it should give 0. If it gives 0, it means you're very good. So why don't we try maybe the ones with negative, okay? I think you can try number 3. Think about how you can do number 3. This number 3 right here, this number 3. Think about how you can factor that one. And also think about how you can, okay, but then maybe we should try, let's go ahead and just try maybe this problem right here, problem number 5. Let's try number 5. So I'll go ahead and just delete everything else. And we're going to try number 5. Again, you can always rewind. So I don't want the video to get too long, but then I would just uh, make sure that I conclude soon. All right. Okay. So I hope this is helping a little. It's not very easy to solve quadratic equations by factoring. But it's not all equations. It's not all quadratic equations that you can solve by this method. Okay? So there are some complicated problems that you cannot solve by factoring, especially when the roots or when the zeros are not real, or when they are fraction, and it's not very easy to carry out factors like factoring like that. All right, so let's go ahead and just solve some of them that are negative. So maybe we should do, maybe try out uh, this problem here. We have 1, 2, 3, 4. Why don't we do 4? Okay, let's do 4 and see. For 4 here, what I'm going to do here is multiply 2 and 6. Again, 2 times 6 gave 12, which is the product. But then I have the sum is negative 13. So sum is negative 13. This is going to be interesting. So the sum is negative 13 and the product is what? Is 12. Good. Since I have a negative number, I have to be very careful here. So what I can do here is this. Okay, so uh, I'm going to look at two negative numbers. Okay, so I want two negative numbers that can multiply to give a positive number. You know, negative times negative is positive. You know that for sure. Yes. So negative times negative is positive. So we need to be very careful with this. Okay, so negative times negative is positive. So because of that, we are going to do negative 1 times negative 12. I know this for sure. So negative 1 times negative 12 is going to be positive. It's going to be positive 12, right? But then if we do discard this -1 and -12 and add it instead. So -1 plus -12, you can see that. If I add them up, what does that give? It gives -13. So it means I'm going to have to replace -13 by -1x plus -12x. So this is what I'm going to do. So I'm going to bring this equation right here down. So I'll write 2x squared minus 13x. I just wanted to write that equation first before I show you my changes. So I'm going to make my changes now. So I'm going to write 2x squared. So now, instead of writing -13x, look what I'm going to write. So I'm going to replace that by -1x plus -12x. Just write it like this first. See what I've done? So -1x plus -12x. Then I'll just add my plus 6 now because that's the only thing left, plus 6. Good. So now, since I've had that done this way, I can leave it this way and just do my grouping, or I can just take my eraser because I know that positive and negative, a plus sign followed by a negative sign would always go to a negative. So if I want, I can just take this positive sign away. Good. So if I take it away, it means I will now have -12. That means I have 2x squared minus 1x, then minus 12x plus 6. That's what I have. So now I am going to group them. So I'm going to group this two and then also group this two. All right. So the common factor right here will only be x. So x is common between the two expressions. So I'm going to factor x out. I'm going to open my bracket. I'm going to have 2x left in that bracket. And then I'm going to have -1. And I'm going to close that out. So to the second, I have -12x plus 6. So 6 is common here. All right. So I'm going to factor 6 out. But if I factor 6 out, I'm going to get in trouble. But I'm probably looking at factoring -6. Okay, so I'm going to try to factor -6 out because this number here is negative. So I'm going to do -6 instead of just factoring 6. So it'll be negative first and then 6 out. So I'm going to be left with 2x. But then when I get to the positive number, the positive, because I'm factoring -6 out, instead of having +1, it will be -1. So again, remember that you're trying to make sure that when you do the distributive property backwards, it will give the original. So you want everything to go back to the original, right? So that's what you're trying to do here. So now x times 2x is 2x squared. X times -1 is -1x, which is good. Now, you have -6 times 2x is -12x. But then -6 times -1 will be +6, which is good. So if you left this part as positive here, you get in trouble. So your 2x minus 1 would not overlap with 2x plus 1. They will not overlap. And then you will not be able to factor. So you want to make sure that you're careful when you have negative signs. When you are factoring, you have to make some changes. Okay? Very different than when you have additions everywhere. Okay, so that's what I have. So now I have 2x minus 1 and 2x minus 1, both of them overlapping. So what I'm going to do here is to just finish it off from here. So I have 2x minus 1 and 2x minus 1. So I'm just going to wrap them up and keep them in one parenthesis, in one bracket. So now I'm going to now take x and -6 together. So I'm going to group x and -6 together as a second factor. So that's how you factor the problem number 4. And if problem number 4 were to be transformed to become an equation like this, all you got to do now is to just use your factored form, which is 2x minus 1 and x minus 6. You set all of that equal to 0 and then apply the zero principal method, and then it will be 2x minus 1 is equal to 0. So 2x minus 1 equals 0, and then you do x minus 6 equals 0. X minus 6 equals 0. So now solve each piece. So if you solve that first one, it's going to be 2x, then you add 1 on both sides. It's going to be 2x is equal to 1 because you're going to add 1 here, and you're going to add 1 over there. That means 2x is going to be equal to 1. And then you're going to cross this out, right? So good. And then you divide both sides by 2 so that x will be 1/2. Then you're going to solve the second equation where you have x minus 6 is 0. If x minus 6 is 0, that means x is at least 6. So in this case, this will be your zeros or the solution to the quadratic equation number 4. So I hope this is helpful, and this is how you can also solve the rest of the two problems, like problem number 5 and problem number 6. You just need to be very careful with your factors. Okay, here if you multiply 2 times 6, that's going to give you 12. Again, if that's 12, then you're looking at how you break 12 down to get -8. So if you have 12, we know that 12 is negative. 12 is actually 2 times 6. Yes, so 2 times 6 is 12. Since I have 8 over here and the sum is 8 and the product is 12, then what I can do here is just, so since I have -8, I will just do here as -2 plus -6. Right, so that would work. So I'm going to use -2x and -6x to actually factor this problem. For this one here, since you have 2 times 6 is 12, which is going to be the product. So if you break that down, you want two numbers that are going to give -7. So you know that in order to get 7 as a sum, you need like 4 and 3. I know that 12 is 4 times 3, yes? And then this is also 4 plus 3. Now, since I have -7, I'm going to have to distribute negative signs, all right? And I'm also going to distribute negative signs. So I know that -4 times -3 is positive 12. And then I know -4 plus -3 is -7, is going to be -7. So that will be -7. So I am now looking at using -4x and -3x to factor the problem. So I want you to also practice, okay? And this is how you can factor trinomials. So I hope this is helpful, and I will see you in the next lesson. Thank you very much.